Chapter 2 in your textbook on page 70. Everybody should be open there. 2.1, the title is, this is the exciting thing I'm going to talk to you about, the, yes, the tangent ratio. Just even the mention of it just gets me excited. The hair on the back of my neck just stands right up. Just like, I want to run out the window and beat my chest and fly. You ever feel like that? Yeah? Okay, I've seen some nods. Okay, it's good. Anyways, so the tangent ratio. Now, how many of you remember hearing the tangent ratio before? Have you ever heard that before? Remember that from grade 9, 8, whatever? Sort of? Okay. It starts off with the right triangle. Okay? A right triangle, as you know, because in last chapter we did a lot of work with Pythagoras' theorem. And again, this isn't the best right triangle. Sorry, it's hard to draw on this little tablet, but that's a right triangle. If you have this little symbol there, that means it's a 90 degree. That means this is a right triangle. Okay. So, this side, A, up there, A, B, and C. Weird. That's on there. Should happen. A, B, C. Now, in Pythagoras' theorem, which you guys all know about, the squares, or the sums of the squares of the legs of a right triangle equal the square of the hypotenuse. And that's written as A squared plus B squared equals C squared, right? If we are talking about a specific angle, let's say this angle is A, right here, okay? This angle is A. Do you guys know that there's some other names for these sides? If we're talking about, in relation to a specific angle. Does anyone remember what this side right here is equal to? There's a certain name for it in reference to A. So if we're looking at A, this is the blank side, according to A. No? Oblique? Not quite, but good guess. There is a word that's like that, though, that you're thinking of. But this one is opposite. Okay? Opposite. Why is this the opposite side? Well, because A is over here, and if you draw a line straight through the middle of angle A, you hit the opposite side. Does that make sense? Opposite. Now, I think the word that you were thinking of is not oblique, but it's close. It is, I think I heard someone say it. Adjacent. Yeah. Now, that could be the word that you were trying to get there just a few minutes ago. But this is the adjacent side. So adjacent is a word that means next to, right next to. Okay? Adjacent side. This side right here, this is right next to A as well, but it has a special name because it's opposite of the 90-degree angle. It's always the largest side in the right triangle. Do you remember what this one's called? Yes, hypotenuse. Very strange word, isn't it? Hypotenuse. Okay. So now this is how you label the sides with these names according to angle A here. And it's important to note that if we're talking about another angle, actually, the opposite side, if we're talking about, this angle right here, then this would be the opposite side, and this would be the adjacent. But I just want to show you this because the tangent ratio is one of the ratios that can be built using the lengths of the sides. So, for example, the ratio of the opposite side to the adjacent side is the tangent ratio. Okay? The ratio of the opposite side to the adjacent side, okay, is the tangent ratio. It's written like this. The tan of A, you just abbreviate tangent as tan of A equals opposite over adjacent. So it's a ratio of sides of a right triangle for an angle that's special. Okay? It's special. Well, why is it special? Well, the interesting thing is that, and this is going to be a little bit tough to understand, but it doesn't matter what size the right triangle is. If you have a certain angle, okay, a certain angle A, the ratio of the opposite side divided by the adjacent side, that ratio, that actual number value, when you divide the two lengths, is going to be the same for this angle, this angle A, no matter what size the right triangle is. That are the exact same shape, but different size, okay? They each have a 90-degree angle, and I've labeled one of these angles as A. Okay? Now, according to A, which side is the opposite side? Is it this one or this one? This one, right. So this is opposite. Which one is the adjacent side? This one or this one? 1 or 2? 2, right. How do I know that? Well, because this is the hypotenuse, because it's opposite the 90. Okay, so I'm going to label that on the other diagrams as well. All right, so I am going to take a measure here, and I'm actually physically taking a measure of the computer screen right now. This is 46 degrees. All right, 46 degrees. So there might be some measurement error here, but 46 degrees looks pretty good. I think it's supposed to be 45 just because the computer generated this, but let's go with 46 for all three of these angles. Okay. Now, what we want to do is we want to measure the side lengths. Okay? And I'm going to do that. The opposite side here is exactly 5.9 centimeters. Okay, so you guys can write this down with me. I'll do the other ones as well. Over here, the small one. Okay. The small one is going to be 1.65. 1.65. And this one over here is going to be 1. Well, it's pretty close, boy. 1.6. And actually, I think I got this mixed up when I measured this. This is going to be 595 over here. Okay, make this 0, and this one 595, please. And finally, this last one here is going to be 13.4. 13.4. These are all centimeters. And this one over here will be 13.5. Okay. So now that we have these measurements, the tangent ratio, we don't need to know what A is, but we're going to find out what the ratio is for A. Remember, the ratio is the opposite side divided by adjacent side. Okay? So what's 5.95 divided by 5.9? Okay, so this ratio here is 1.008. Let's do the same for this one over here in green. So 1.65 over 1.6 is the tan ratio for A over here. And if we do that on our calculator, 1.03, okay, for tan A here. And over here, let's do 13.5 divided by 13.4. 1.007. Okay. Now, obviously, these are pretty close, right? 1.008, 1.007. 1.03 is quite a bit bigger, but this is a small, very small triangle. So with using the same measurement tool here, it's a little bit tough to get it really accurate. So this number is a bit off, but I just wanted to show you that this tangent ratio, if we have the same angle here, but different size, so the sides are different lengths, that it's the same ratio. So that's why it's a special ratio. Okay? And let's just, for kicks here, do you guys see on your calculators you have sine, cos, tan? This is, SIN is sine, S-I-N-E, that's short for sine, cosine, and tangent. This is the tangent button. This is why you need a scientific calculator, okay? Because you need to use these functions. And if we did tan, all right, of 45, and I just want to double check that I'm in degrees, I'm not. This calculator, you can switch between degrees and another measurement, which I'll teach you about another time. Tan of 45 is, look at that, 1. Oh, I should have done tan of 46. Tan 46 is, look at that, about 1.03. So actually this one is probably a little bit more accurate than these ones. But do you see how the calculator already has programmed in these special ratios? So tan of 46 should always be about 1.03 or 1.0355. So it's a special ratio. And because right triangles are restricted with the angles, right, the sides should be the same. I mean, the ratio of the sides should be the same. So that's the tangent ratio. In calculating the tan ratio, let's say we have something like this. We have 4, we have 3, and we have a 90-degree angle. Okay? And let's say that we have angle D is right here. So go ahead and calculate for me tan of D. Tell me what tan of D is. So using the values of the opposite side, so tan D equals 3 divided by 4. The ratio of tan D is 0.75, or 3/4. Okay? That's the ratio of the sides for angle D. Now, please don't say this. D is 0.75. That is not correct. Okay? And students sometimes do that. They go, oh, D is 0.75. No, no, no. The tangent ratio of angle D in this triangle is 0.75. Okay? Let's do another type of example. So this is an example where we can use the tangent ratio to solve for an unknown side. What you have to remember is that the tan of 38 degrees, that's this angle right here, is equal to the ratio of the opposite side 4 divided by the adjacent side x. And so you can set up a very simple algebraic equation, and you can solve for the missing side. So you see how we have to solve for the unknown side x right here? That's what's unknown, that's what we need to solve for. Okay? Well, what do we do with this right here? What do you do with that? Well, the easy part about this is you just plug this into your calculator and you can actually use the number. So your calculator, turn that on. Tangent 38. That's all you gotta do. Tan 38 is. There you go. There's your number right there. And that number can be put in place of this expression tan 38, because that's the ratio value. So 0.7812856. 2856. Yeah, use as many decimal places as you can. Okay. And to solve for x, okay, I'm not sure how good you are at solving for variables. It's very important in this class. By grade 10, you got to know how to do this. You got to get that x out of the denominator, so multiply, both sides of the equation by x, right? Multiply both sides by x. That will eliminate the x over here, so you just have 4 left over here. This becomes 0.7812856x. And then you divide by this number to get x all by itself in the top there. Divide both sides. 5.12. So that's our missing side, 5.12. Now if I guess this angle right, which I didn't actually measure it, but if this is 4, okay, so this is a little over 5. So it makes sense, it's a bit bigger. And that's what we calculated the length of our side to be. Okay, so what happens if you're given this and you're asked to solve for A? A equals what? Okay. Well, you can use your calculator for this. You don't have to. All you have to do is use your calculator, but let me show you how to use your calculator to solve for A. You're given the value of the relation, right, or the ratio. And so on your calculator, yours will be a little bit different than mine, maybe here, but you have a tan function, and you also have an inverse tan function. You see that tan to the negative 1? Okay? What you're going to do is you're going to try and solve for A here by basically taking the inverse tan of both sides. And that looks really scary. It's not. All you do is this. Second function tan. You see how it throws it up there like that? And then you put in 3/4. 3 divided by 4. And so you're saying, okay, here's the ratio. I want to find what angle that is. Hit enter. There you go. 36.87. So A equals 36.87. That's the angle that yields this as a ratio. All right? Okay, I'm going to give you a few questions to do, and I want you to do them on your own, see if you get the same answer as me, then you'll be able to know whether you have any questions or not. First question, solve for A given this right triangle right here. And I started it for you, right? You want to write tan A equals. What number do I put up here? Sorry? What is it, the opposite or the adjacent that goes up here? Opposite. So what's the opposite to A? 10. Good. And over here, down here is 7. Okay, so go ahead and do it just like we did in this previous question. Take a moment to just solve for A. So again, what you do is you second function tan this ratio, and then you've got your angle. Yeah. Okay, any questions? Yep. Okay, so if it's the angle that you're looking for, then you do tan to the negative 1 of the ratio itself. Okay? If you're looking for the tan ratio, if that's what you're looking for, then you just do, then you just do the ratio itself. Okay, so it's just the numbers. So you do the second function only when you're looking for the angle. Right here. Okay? Only when you're looking for the angle you use the second function. Your next question is a bit tougher. You got to do one more step here. And I'm going to let you just see if you can figure out what step you need to have to do. But I want you to give me the tan ratio for A. So go ahead and do that. Okay, so this is just the start. I'm not done here yet, but I just want to let you know where we're at here. If you are having trouble getting going, again, we need to find the adjacent side, which is right here. It's not given to you. So we need to find adjacent using Pythagoras' theorem. So we would set this up. Here is A for adjacent. A squared plus 5 squared equals 10 squared, right? To solve for A, you want to move the 5 squared over to the other side, which represents this, minus 5 squared from both sides. So you have A squared equals 100 minus 25, or A equals the square root of 75. Okay, because we have a squared and we want to get rid of that squared, we have to square root, right? So that gets A by itself, equals the square root of 75, which is about 8.66. So now you know that this is 8.66. So your final steps would be tan of A equals opposite, that's 5, divided by 8.66. This is your ratio, so this is the answer to the question. The tan of A is 0.5774. Does that make sense? Does that look right? Did anyone get this answer before I got it? Okay, 3, 4 of you. Okay, so that's a question that you're going to be practicing. I would ask you just one more quick question here, just to make sure that you realize or you understand the second part of what we learned today. Can you tell me from this question, what is the value of angle A? Go ahead and find out what angle A is. Go ahead. well, this is what we've got so far, right? Tan of A equals this. Get on your calculator. In order to find A, we do second function tan of that ratio. No problem. Equals 30 degrees. See that? Angle A, 30 degrees.